हरि करना।
So with this, we have answered your some of your questions. With the first question, what's the chances of happening this or that event? For that, we have answered that question is answered using the addition rules for probability, dependent on whether the events are mutually exclusive or mutually not exclusive. And you have answered the one more question saying, okay, that's fine, but what are the chances of happening both events, this and that and this, both at a time? What are the chances? You asked that question, and I told you using probability. For that, we use multiplication rules for probability. They're dependent on whether our variables, whether our events are dependent or independent. Based on that, we will do the calculation. Now, the third way of asking a question, the human asks this way also, human thinks this way also. What is the chances of happening that event after this event has done? Okay, what's the chances of happening, what's the chances of happening that event after this event has been completed? So that's the next way of questioning, next way of thinking, next way of asking these questions, the next way of thinking. So let's answer this question using conditional probability, using conditional probability. So the conditional probability is another way of answering your question of what's the probability of happening that event once this event has been done. Okay, so if you put it in completely proper way, so conditional probability is the probability of an event A occurring given that another event B has occurred. That's what. Okay, what's the chances of happening event B after the event A has been occurred, has occurred? So that's what is. So this is what we call it as a conditional probability. First, let's see conditional probability for independent events. What happens if the events are completely independent, like flipping a coin and rolling a dice? So two events are independent if the occurrence of one event does not affect the probability of the other event. So two events A and B are independent, then their conditional probability. The first one is probability of B given that A has occurred. Second one is probability of A given that B has occurred. So in this case, A should be done to B should start. A should be completed. If you want to get the B, if you want to occur the B, if you want B to occur, B to happen, A should be completed first. That's what the denotion here. That's what it denotes. So probability of B given that A has occurred is equal to probability B, because those are independent. So there is no dependency of B on A. Simple. That's it. And same thing, probability of A given that B has occurred, that's is equals to probability of A, because there is no dependency of A with B. But you may ask the question, that's why I'm answering your question. You may ask this way, what's the chance of happening that event after this event? That's what you will ask now. That's why I'm answering. If the events are independent, then there is no relation. It's pretty straightforward. This is what you get with the conditional probability. Let's take example. So if the events that are not independent, if they are dependent, then the condition would be completely different. Okay. So, but let's decide if the events are independent or dependent. First, let's see that. Selecting a diamond from a standard deck of cards A, putting it back in the deck, and then selecting a spade from deck B. What is that? So, probability of B given that probability of A, that is equals to 13. Probability of B, like how many you have selecting a spade from deck. So selecting a spade, you have 13 spades out of 52. So obviously it's 1 by 4 probability of B given that A, because first one is selecting a diamond from a standard deck and a spade from a standard deck. This is deck of cards A, this is deck of cards B. Selecting a diamond from standard deck of cards A, putting it back in the deck, and then selecting a spade from deck B. Okay, so these are completely independent events. So 13 divided by 52, 1 by 4. Or if you just calculate the probability of B, 13 divided by 52, same thing happens, because those are independent events. When those are independent events, even if you ask for what's the probability of B given that A has occurred, it's same as probability of B happening or B occurring. That's it.